in Oxford, supported by Professor Allen, and our work predominantly revolves around organising weekly events, educating the students, undergraduate, graduate, and fellows of Oxford on a range of issues relating to climate change. We also produce blogs with a similar intention. We're delighted today to welcome both Professor Allen and also Raina Lal, who is a lawyer from Fiji, who will be chairing today's event.
Thank you, Rupert. Thank you, everyone, for joining us here today on what has become a rather dreary grey afternoon in Bonn. And it's a Sunday, negotiations are a bit slow, and probably we are all in the same vein. So thank you for taking the time out on your Sunday then. Today we're here to discuss, well, the name of our side event this afternoon is Emission Budgets and Pathways to 1.5 Degrees, a context of the global stocktake. And today's side event is based on a paper that Professor Allen co-authored, which was titled Emission Budgets and Pathways Consistent with Limiting Warming to 1.5 Degrees. And this paper generated a little bit of chatter, so we thought that it would be appropriate to maybe come forward and have a chat about the paper and the science behind it. And so today we have Professor Allen here to basically speak to the research that him and his co-authors conducted in this paper that was presented. So for many of you here, you are probably familiar with Professor Allen and his work. If you aren't, though, Professor Allen is a professor of geosystem science at the University of Oxford. He is also the leader of the climate research program in the Department of Physics. And he also works within the School of Geography and Environment at the University of Oxford. He has been a lead author with the IPCC for going on 2 decades now. So he does have quite a lot of background in this area, as many of you would know. So you didn't come here to listen to me chatter all day, so I'll hand over to Professor Allen. Thank you.
Thank you very much, Kaya. Although I hope we'll come back to Kaya's areas of expertise when we get to the Q&A, because our starting point here partly has to be, why do we care? Why do we care how hard it would be to limit warming to 1.5 degrees? So this paper that I'm talking about here was specifically addressing the question of how much carbon can we afford to put in the atmosphere and still expect temperatures to remain below 1.5 degrees Celsius above pre-industrial levels. And it's important straight away to put this into context. By the way, this was an international study. It was led by the University of Oxford. We had a number of British collaborators, we had Norwegian collaborators, we had one Canadian collaborator, Damon Matthews, who's here as well. And so one of the things that we discovered as soon as this paper came out was the number of people who wanted to seize on the results we showed as saying, we can relax, we don't need to do anything. So I need to make it very clear straight away whether we're aiming for 2 degrees or 1.5 degrees, and completely independent of the arguments academics are having over what you will see boil down to tenths of a degree, and that's kind of what we're talking about here. We need to start reducing emissions. We need to start reducing emissions now, and we won't know until we start reducing emissions just how hard it's going to be to achieve any of these temperature goals. So that's the overall context of all of this. That said, the question of whether or not 1.5 degrees is achievable, or at least achievable in principle, or was achievable in principle when the Paris Agreement was signed, is of course very important for the kind of things that Kaya is concerned about as a lawyer. What are the legal implications of 1.5 degrees for things like loss and damage? The question of whether or not we could in principle achieve it becomes very important if you're asking whether parties to the Paris Agreement can in some way be held responsible should perhaps they fail to achieve it. So that's a very important reason why this discussion about how feasible is it today to achieve 1.5 degrees becomes very important. So when the Paris Agreement was first signed, a lot of us in the academic community looked back at key figures in the IPCC Fifth Assessment Report, and this is one of them, to ask the question, well, how feasible is this 1.5 degree goal? So this is one of the key figures from the IPCC fifth assessment, published in 2013, which shows the total amount of carbon we dump in the atmosphere in the horizontal from 1870 against the warming we see from the same time in the vertical. And you can see that the point of this figure was to draw attention to the overall linear relationship. The more carbon you put in the atmosphere, the more warming you get, and it's pretty much independent of which scenario you follow. These different scenarios are different, range from a very aggressive mitigation scenario in blue to a sort of business as usual scenario in red, and they're all following more or less the same straight line. So just looking at this kind of figure, you can draw a line. Initially, people were drawing lines at 2 degrees, but straight after Paris, people started drawing lines at 1.5 degrees. See, at what amount of carbon do a certain number of the models, say a third of them, exceed 1.5 degrees? And that would give you a total amount of carbon consistent with limiting warming to 1.5 degrees with a given level of probability. That's the kind of question you can address with this graph. And these are the numbers that come out. And so this is what the sort of thinking was when we started our study. If we look at this so-called CMIP5 ensemble of models, this is sort of the available large-scale climate models, starting from 1870, it looks as though the budget for 1.5 degrees would be about just over 2,000 billion tons of CO2. And then you look at the observed numbers and say, well, we've actually already emitted by 2015 about 2,000 billion tons of CO2. The amount remaining is very small, and looks like only sort of 3 to 5 years. So, on the strength of that, people said, well, we've almost exhausted the budget for 1.5 degrees already. And so on the strength of these numbers, which are the sort of back of the envelope calculations you could do immediately after the Paris Agreement, it looked as though it was just a lot of people said, well, it's just an aspirational goal. There's actually no way of actually achieving it, or at least there's no way of achieving it without actively intervening in the climate system, either, well, to, say, for example, shelter the planet from the incoming radiation from the sun, sort of various very aggressive measures of geoengineering. However, if we zoom in on this figure, so this is just exactly that same figure, but I'm just zooming in on the critical lower left corner of it, and look to see where we are today. We're sort of about here, we were about here in 2015. So that corresponds to around a degree of warming and about 540 billion tons of carbon, or just over 2,000, so that's the 2,000 billion tons of CO2. I'm trying to remember I'm at COP now, so I have to talk in tons of CO2. Climate scientists all talk in tons of carbon, and so I always have to keep multiplying by 3.7 in my head, which is hard. The crucial point you can see here is that there's a very broad range of responses, simulated warming, in the climate models at the point the models reach that 2,000 billion tons of CO2 level that we've reached today. And we're not actually, that's because these models were started off in the 19th century. And they were run forward to today, and there's therefore a big spread of responses from the models. But we aren't actually that uncertain about what global temperature is today. It's not that high, it's probably not that low. So we can use that additional information about where global temperatures have got to today. Do you want to come in and you're more than welcome to come if people shuffle in and maybe take some spots at the front. Thank you. Thank you very much for joining us. I was explaining just explaining the context of where our calculations began here, which was the fact that the information we had available at the time of Paris from the academic community wasn't very well suited to asking the question of how much carbon we can still afford to put in the atmosphere and keep temperatures below 1.5 degrees. In some sense, as an academic, I have to say it was a little embarrassing how unprepared the academic community was for the Paris outcome. Many academics thought that the question was, how do we maintain temperatures below 2 degrees? And we'd done a lot of research onto that. And suddenly, coming out of Paris, the question was, we were asked a different question. So we felt almost like my students sometimes complain when they get a question on the exam and they say, but this wasn't the question you said you were going to ask. And then, then they write in their feedback forms, this was a harsh exam, And so the world's climate scientists felt a little bit like students who were given a slightly unexpected question in the exam coming out of Paris. So that the High Ambition Coalition succeeded in changing the subject, changing the topic of conversation, and set us all a new and really challenging academic question to address. And the point is that if you're trying to work out how much warming there is left, but how much carbon dioxide we have left before we push temperatures over 1.5 degrees, it's not a good idea to start by pretending that you're this uncertain about what the temperatures are at the moment, because then you're taking the difference between two very uncertain numbers, which is a very bad way of estimating anything. So we can actually look at temperatures, recent temperatures, and the drivers of recent temperatures. And in fact, there's another side event tomorrow at 3 o'clock in room 11 where we're going to be talking in much more detail about this. But we can estimate how much warming over recent decades has been due to human influence on climate and how much has been due to other factors, and separate these things out. And we can get an estimate of the level of human-induced warming today, which is about 1 degree above pre-industrial. So it's much more precise than the range in the IPCC models. There are IPCC models that give this level of warming, but there's also IPCC models that give much higher ones and somewhat lower ones. So we can get rid of that uncertainty by taking into account more carefully where we are today. This is just showing you the unpacking that model, that picture I showed you from the IPCC Fifth Assessment Report, so you can actually see the models themselves underneath it. So these little wiggly lines here correspond to individual models which went into that estimate of the 1.5 degree carbon budget. And where we've put little dots here, these red dots, those are the models, the 1/3 of the models that first cross the 1.5 degree threshold. And you can see that that set of models are already well above observed temperatures today. So not all the models are above observed temperatures today, but the ones that determined the 1.5 degree threshold in the IPCC Fifth Assessment Report are well above temperatures observed today. So it's not that they're all wrong, but if you're trying to identify a budget for staying lightly below 1.5 degrees, you're interested not in all of the models, but you're interested in the warmest ones, because you're asking which are the first ones that cross 1.5 degrees, and those models that are warm at the time they cross 1.5 degrees, the first ones to cross 1.5 degrees, are also the ones that are warmest today. None of this matters if you're talking about 2 degrees or 4 degrees, because you can see these lines tangle up. The fact that they're all going up together is all that really matters when you're talking about these higher levels of warming. But if you're talking about a little short-term trajectory, and we don't have much space between where we are now and 1.5, then it matters a lot. So the obvious thing to do is, it's exactly like, say, for example, an analogy would be a hurricane forecast. You imagine you're forecasting a hurricane, you've got tracks for the hurricane coming out of your forecast model, and then, which was started 5 days ago. Okay, so just like these models were started back in the last century. So you've got all these tracks in your forecast model, and then you take you see where the hurricane has actually got to. You obviously use that information to say where the hurricane is going to go next. And when they update the hurricane forecast, normally journalists don't say, the hurricane forecast models are wrong, therefore we should now ignore the hurricane forecast. Okay, it's a matter of updating the forecast and using new information as it comes in. Of course, we did have people reporting when we first published these results. In fact, I think we had the headline, "We were wrong, admit climate scientists." And as I say, the point of this is just using new information as it's coming in. We're not saying you can throw out the entire modeling framework. We're just using the information about where the models are now in order to say where they're going to go next. And using in particular the fact that all of these models are going in roughly the same direction. So we can take them, by the way, that's where in the structured expert dialogue before Paris, that's where the Paris delegates were told temperatures had got to 0.85 degrees above pre-industrial. We'll come back to that in a minute. So now we can just take exactly the same information, but instead of starting everything from 1870, we just start everything from where we are now. And because where we are now is, or the temperatures of the current decade, we're sort of well over 2/3 of the way through the decade by now, but because the temperatures of the current decade are about 0.93, 0.95 degrees above pre-industrial, we could approximate a 1.5 degree future as meaning 0.5 to 0.6 degrees warmer than the current decade. So it's just another way of framing the challenge. And if you do it this way, of course, you completely solve the problem of the models being all over the place today, because they're not. I mean, by definition, you're starting them all off from the same point. And you can then ask, well, where are we going? And you can see there's a general pattern, which is exactly what we've seen in all of these simulations, roughly 2 degrees per trillion tons of carbon, or half a degree per trillion tons of CO2, which is now completely consistent over the short term as well. And we can therefore use this information to give a much more accurate estimate of the amount of warming left before we get to 1.5 degrees. So here's just zooming into the corner of that figure, and you can see we're now looking at about 200 billion tons of carbon, so that's now more like 800 billion tons of CO2 left to burn from 2015 before we before even we have a better than 1/3 chance of going over, I should say probably worse than 1/3 chance of going over 1.5 degrees. So this research, when it was published, immediately caused quite a storm of quite a few objections raised and quite a lot of comments raised, and we're obviously that's the nature of academic research, as you put results out there and people comment on it and so forth. 3 important questions have come up. I'll just sort of address those and then we'll go over to questions, but I thought I'd sort of tell you the questions other people are asking, at least, to frame our discussion. First of all, most of the discussion actually was around something which we just used as our starting point, was this assumption that we were, or this assertion that we are currently between 0.9 and 1 degree warmer than pre-industrial. And several people point out, well, there are ways of defining pre-industrial and ways of defining global temperature which would put us at 1.2 degrees or 1.3 degrees already. And this is actually something I would actually be really interested in hearing from delegates on. How important was it in the discussion around the Paris long-term temperature goal, the information in the structured expert dialogue that we were now at 0.85 degrees above pre-industrial? Because in the structured expert dialogue, in the build-up to Paris, we have a very clear statement that temperatures are now 0.85 degrees above pre-industrial. There are plenty of academics who are arguing, well, we could use a different definition of pre-industrial. If we go back another 100 years beyond 1850 to 1900, we'd be at 1 point something degrees already. But perhaps, you know, if we've started from the premise that we're at 0.85 degrees, we need to work from there. That's the sort of logical way of making these goals consistent with the Paris Agreement. So we would argue that this sort of argument about pre-industrial has almost been solved for us by the Paris Agreement itself, by just saying that's what they decided pre-industrial means, and so it really doesn't matter if somebody else comes up with a different definition, because that's what the definition that the Paris Agreement is using. But this is me sort of as an outsider sort of interpreting what the Paris Agreement means by pre-industrial, and I'd really be interested to hear from people much closer to the process, actually what the thinking is on that. There's another still very widely held view that there is a certain amount of warming so-called in the pipeline, or there's some inertia in the system that even if we stopped emissions now, we'd still see some more tenths of a degree of warming in the future. this is plain wrong, and I'll explain. I'll show. In fact, Damon has done a lot of work actually to show that that's not correct. And the third, so I'll show you some of that in a minute. And then the third point is that we were optimistic in this paper about other forms of atmospheric warming pollution in the future, and that's a very important caveat. So, that's actually turns out to be the most important issue in determining the future carbon budget. First of all, this point about the amount of warming in the pipeline. This is a nice. Is that your figure, Damon? Okay, sorry. I realised I'm not quite sure where it came from, but there are similar papers. There are similar figures in Damon's papers. I'm not quite sure. Anyway, it's probably sort of it's probably adapted from one of your papers. Anyway, so this shows what happens if you stop emissions in 2050. Yeah. So just imagine hypothetically you've got emissions carrying on and CO2 concentrations in the atmosphere being pushed up. And then suddenly in 2050, you stop emissions. That's the red line here. And you see the temperatures, this is the temperature response to that, it goes basically flat. There's no big overshoot after the point you stop emissions. So past emissions don't commit us to future warming. Future warming is driven by future emissions. And that's a really important point that people need to understand, because it bears on the question of, what was the situation actually when they signed the Paris Agreement? The situation was our past emissions had committed us to the degree of warming we were already experiencing, but no more. The next question is, were we over-optimistic about other sources of warming? And this bears on other estimates of the outstanding carbon budget. And for example, the UNEP Gap Report, which you can go to the launch of on Tuesday, they give an outstanding budget of 400 billion tons of CO2 from 2015, which you'll notice is about half the budget that we reported in Millar et al. So there's that 400 billion tons of CO2. But there's actually a very simple explanation for that discrepancy. So this is not an uncertainty per se. This turns out to be just different assumptions underlying the two analyses. And this figure, which I apologize for the number of wiggly lines on it, but that's the explanation. You only need worry about two sets of lines here. One is the green line, which was the scenario we used for future forcing, and of which the dotted lines here show you the non-CO2 contribution to that future forcing. That's the green line. The black lines are future forcing, that's the radiative imbalance, in many other scenarios. And you'll notice that most of the black lines are above the green line, even though they all have about the same CO2 forcing in the future. So most other scenarios assume that we should expect more warming due to non-CO2 drivers of climate change. So that's methane, black carbon, these other forms of pollution. Most other scenarios than the one we were using assume that we should expect a net warming due to other agents above the warming we get from CO2. And there's a very useful equation that I think everybody in this conference should know. It's very useful because it's a very nice round number. 1 watt per square meter, that's a measure of how much energy imbalance changes over decades. 1 watt per square meter is worth about 1,000 billion tons of CO2. So in other words, that's 400 billion tons of CO2, that difference between these scenarios in terms of the amount of energy imbalance in 2050. So immediately you see where the difference comes from. The difference comes from not uncertainty in the climate response or different assumptions about sort of where we are now. It just comes from different assumptions about how successful we will be in mitigating other forms of global warming pollution. So in the scenario we were using, well, it was a pretty optimistic one. It assumed that we'd be quite successful in reducing non-CO2 warming agents. Other scenarios are more pessimistic and therefore, of course, then leave less room for CO2. But there is, arguments, including presented in the UNEP Gap Report itself, that there is a lot of potential for alleviating these other forms of global warming pollution. This shows actually the impact of methane and the impact of black carbon reductions, or potential black carbon reductions, in the UNEP Gap Report. And they actually estimate that we could get as much as 0.2 degrees of cooling by 2050 just from black carbon mitigation measures, which are not included in our scenario. So, you know, there's swings and roundabouts here. We were using a relatively optimistic scenario about non-CO2, about these other forms of pollution, but there are opportunities out there that mean that this scenario is not out of the question. So where does this put us? Well, okay, this is the sort of bewildering diagram from the figure, but I can show you a much simpler version of it in a minute. What it basically comes down to, if we can follow a trajectory like RCP 2.6, like this particular scenario for future emissions, we actually have more or less even odds of limiting future warming to 1.5 degrees. Let me put that a lot slower. So rather than all of those lines, I'll just show you one. If we don't reduce emissions, we're looking at 4 degrees of warming or more by 2100, and sustained additional warming thereafter. That's where we're starting from. And we all need to note that that's pretty much the trajectory we're on, until emission reductions begin. But if we manage to reduce emissions to net zero by around 2070, there's still a range of uncertainty in the climate outcome, and that range extends up to 2 degrees and maybe even slightly higher. But the sort of 50-50 warming in 2100 under that scenario is around 1.5 degrees. So one could easily argue that that consists in doing a pretty good job of pursuing efforts towards 1.5 degrees. And finally, of course, it's not too late, because emissions in 2017, as I stressed earlier, don't commit us to future warming. It's the emissions in the future that matter. That's the sort of scenario we're talking about. And while it's very important to say, although this is achievable, it's not the path we're on. It's not even the path that we are being put on by the Paris pledges. And it's certainly not the path we would be on if we carry on building high carbon infrastructure. So to achieve this kind of rapid reduction, particularly this kind of rapid reduction after 2030, we need to starting to think very hard about the infrastructure we're putting into place today. So the bottom line, do efforts to pursue, to limit the temperature increase to 1.5 degrees above pre-industrial, do they have any chance of success? Okay, and this is a crucial question, because if they don't, then you could argue that it was just an aspirational goal, that it doesn't really mean anything, because even when they signed the Paris Agreement, it wouldn't have been possible to limit warming to 1.5 degrees. So, like any academic, I will always say, well, it depends, okay? So, it depends, of course, what you mean by global temperature and what you mean by pre-industrial, okay? But using the definitions that were used in the Structured Expert Dialogue, that was the basis of the Paris Agreement, the remaining carbon budget from 2015 to keep global temperatures likely below 1.5 degrees is, and if we make assumptions, optimistic assumptions about other climate drivers, is around 800 billion tons of CO2. That is equivalent to reducing emissions in a straight line to zero by around 2070 so that would be equivalent to reducing emissions in a straight line to zero by about 2055. Sorry, you can tell I was trying to do maths in my head at that point. So that's 20 years of today's emissions, but that doesn't mean, as some journalists were keen to interpret it, oh, that means we got 20 years to do nothing, because of course, if you keep today's emissions at 20 years, then you'd have to drop them to zero overnight. So no, it means if you want to get them, if you want to stay within budget and you want to pursue a sensible path downwards, it means following a line which will take you to zero shortly after 2050. And that's equivalent, therefore, reducing emissions in a straight line to zero in 2055. The reason this matters, and why we were keen to have Kaya here, who knows all about loss and damage, is that the achievability in principle of the Paris long-term temperature goal plays a crucial role in what it means should we miss it. And the crucial conclusion of our research, and other research that is coming to similar conclusions, is that Paris was not just an aspirational goal. It could be done. We cannot guarantee it can be done because, of course, we don't know everything we would need to know about the climate response to do that. But there is still a very good chance that we could maintain temperatures below 1.5 degrees, but only if we pursue very aggressive mitigation measures now. On that, I'm sure there'll be questions, at least I hope there'll be questions anyway, and over to you. Just to remind you, we do have a roving mic for questions, and as I say, if they're policy-related questions, I'll probably try and bring Kaya in, or there may well be other people here. If people feel they want to answer each other's questions, that'd be great. But if you don't want to be recorded, I'm afraid we have to ask you, please don't ask a question, because we're recording everything. Sorry, we've slightly mistimed this. Can we? Typical academic. What we'll do is just take technical questions. I was just getting and Rupert's just reminded me, I was getting my script. Let's just take technical questions on what I was talking about now, and then Kaya will speak, and then we'll have a longer discussion. We'll probably run on a little bit over 40, but we have the room for an hour, so we should be all right for that, if that's okay with everybody. Yep.
So this is a technical question, so it'll be fairly quick. So I'm having trouble dispelling this notion that we don't have any baked-in warming with emissions we've already put out. So you're saying that there's no lag time scientifically between the CO2 emissions and the time when we feel the warming?
No, I'm very happy with that as a technical. There is a lag in the thermal climate system because the ocean has some inertia, but the way the carbon cycle responds compensates for that. So you can see here, when we zero out emissions, concentrations drop a little bit immediately. They then go flat. So we have a sort of immediate reduction, and then they sort of kind of flatten off. But that immediate reduction is enough to compensate for that short-term thermal inertia in the oceans. So we have this neat compensation, and because the carbon, and this is the bit people don't always remember when they're talking about this baked-in warming issue, and it's that compensation which helps us out on that one.
Well, what about any sort of limit on that inertia from the ocean? I mean, the ability of the oceans to absorb heat.
I should stress, I am talking about here low injection scenarios. I mean, well, it's what is low, but we're not talking about driving emissions up to sort of RCP 8.5 levels by the end of the century and then switching them off. If you perturb the system far enough, the ability of the carbon cycle to take out the CO2 you've already put in there becomes seriously compromised. And so then you do have substantial baked-in warming. But if we stop emissions at the levels of CO2 and the levels of warming we're at today, or we're at over the next few decades, most models indicate relatively little baked-in warming, 1/10 of a degree tops. But that's a result that is conditional on us being at a low-end scenario.
Thanks.
Thank you, Professor Myles. I just wanted to clarify the 800 billion tons of the carbon budget up to 2055 to have a good chance of staying below 1.5 degrees. Is that CO2e? And if so, is that using the GWP 100? And sort of the follow-up question is, if that's the case, then can we perhaps remodel it using like global warming potential with between now and 2055, so whatever that is.
Okay, these are all questions we would love to talk about at tomorrow's session on metrics. No, these are carbon dioxide budgets,
right.
And that's why when we talk about other drivers of climate change, I was talking about just the amount of forcing they were causing in 2050 or around the time of peak warming. You can't, my view, strongly held, is that you can't sensibly frame a CO2 equivalent budget the way we normally define CO2 equivalents. But we can have a longer and probably more technical conversation about why I believe that's the case offline.
Yeah, thanks.
Shall I? Yeah, I'll take. Should we maybe take one more technical question and then bring Kaya in? Yeah. because I'm sure there are going to be sort of policy-related questions to come in here as well.
Hi, Hector, Head of Modelling, Cambridge Econometrics. Thank you very much for the presentation. Very much enjoyed it. I remember that the media splash and was I was sending frantic emails
Splash or
around.
bloodbath or whatever you want.
Well, I was actually in Korea at the time, so 8 hours ahead of everybody else, and trying to get answers to all of this. There's a question I wanted to ask was it's sort of linked to the question here. Was how dependent are results on the sort of the recent trends, the hockey stick stuff, and things being cooler than expected in the past few years, and how much do we know about those trends?
Well, that's a really good point, and so this sort of illustrates this quite well. We are talking in this study about human-induced warming, i.e. the estimated warming due to human influence on climate once you've got rid of the impact of volcanoes causing temporary cooling or El Nino causing temporary warming. And if you look at this line here, the orange line is human-induced warming, and the black line is what actually happened. So we had a few years here, around 2010 or so, where temperatures were quite substantially below the human-induced warming trend. So that's the famous hiatus, or whatever it's called. So as you can see, our estimate of human-induced warming doesn't really drop during that period. So we would argue that we have succeeded in getting rid of the impact of these temporary fluctuations. Now, you know, that inevitably is it's a statistical separation exercise, so you can never completely prove that we've succeeded in doing that, but we've certainly done our best. Great. Should bring Kai. You want to talk a bit about context?
Yeah.
Great.
Good afternoon, everyone. For those of you who popped in late, my name is Raina Lal. I'm a barrister and litigator from Fiji, and I work predominantly in and around loss and damage here at the negotiations. That would be the negotiation stream I follow, and generally compliance and legal issues. So Myles brought me on board, basically, Myles and Rupert brought me on board basically to speak to, you know, the hot topic of 1.5 degrees and how that plays into loss and damage. And so what we have to remember is that within the Paris Agreement, 1.5 came out and became quite a buzzword, a buzz number. But the Paris Agreement actually aims to target warming to 2 degrees with then significant efforts to reduce to 1.5. So the initial aim was 2 and then 1.5 if we then meet that. 1.5 degrees essentially came out of the High Ambition Coalition, which was in Paris, which was driven by the late Tony de Bruym from the Marshall Islands. And so he was probably the spearhead behind getting 1.5 degrees into the text. And 1.5 degrees also then became the red line of sorts that Pacific Island leaders drew in Paris and said that if 1.5 wasn't in the agreement, they were walking. And this brings us to the 2 points, and I'll address it from 2 aspects of as a lawyer and as a litigator and as a person from the Pacific. From a legal point of view, for a country to commit to something that they knew that potentially they might not have been able to meet, so this 1.5 degree target, if they knowingly went into the agreement and signed it and were aware at the time, that, you know, that it was unlikely that they were going to meet it. This potentially opens up a host of legal questions of whether this brings into some sort of mental element behind their actions and whether then litigation is possible on them knowing that they weren't going to meet this target but then signed on to agreement anyway. It also brings into questions on whether individuals within countries could then take action potentially against their host or their home country on the grounds that they are then not meeting this 1.5 degree target or this target that they tried to commit to because of under the NDCs and what the numbers that they were then putting forward. And right now, the legal system, much like academia, we're working, you know, in a very grey area, mostly because the legal system was not created to deal with a phenomena like climate change, and we are really playing catch up. And at the moment, because our legal system is not one that was built to deal with such an uncertain phenomena, we are very constrained in what we have until such time that we can adapt and further develop our legal system to actually address these issues. As a person from the Pacific, 1.5 degrees, and a lot of people would have heard it, is that there's a mantra or a slogan that goes around, it's 1.5 to stay alive, 1.5 to survive. And that's very true. So for a lot of the Pacific Island nations, a lot of our smaller islands, so Kiribati, Marshall Islands, Tuvalu, they're, a few meters above sea level, and the direct correlation of a 1.5 or 2 degree temperature rise has then a flow-on correlation with how much sea level rise that we can potentially see out of that. And for many of these islands, sea level rise is then the biggest issue facing whether into the future, whether people can remain on their islands, whether they can retain claims over their exclusive economic zones, and so on and so forth. So 1.5 degrees, we and I'm going to say this is from personal opinion, we don't particularly look at 2 degrees as being a target we want to meet. Because we say 1.5 degrees to survive, but 1.5 degrees doesn't necessarily mean that we're going to be able to live and thrive. It means that the lives and the lifestyles that are happening now are going to be very different from what we would see in a 1.5 degree world. In some areas of the Solomon Islands, smaller outer islands that were deemed to be fundamentally stable and on maps 30 years ago are now no longer there. And while these might be very small pockets of land, it does show us a very worrying trend that if we're going to see much higher levels of warming, beyond 1.5 degrees and much higher levels of sea level rise, what this actually means for us as a people. Within loss and damage, the loss and damage framework, and I am almost done, so not to put anyone to sleep. Within loss and damage, for those of you who aren't familiar with it, is essentially addressing the impacts of climate change that can't be mitigated or can't be adapted to. And it addresses both economic, so infrastructure damage, very traditional forms of damage from climate change, and non-economic damage, so things like loss of lives, impacts to culture and heritage as people are dispersed, and impacts on cultural lands, etc. So with this, the higher the temperature rises, the more money that countries are going to have to fundamentally pay out to address loss and damage. And it's a logical assumption that if the temperature gets higher and we're seeing more and more climate impacts as a result, you're then going to have larger impacts from climate change, and therefore the amount of money that's going to be needed to address these will then become much larger. So from a loss and damage standpoint, reducing or aiming for that 1.5 degrees is very important as a means to prevent billions upon billions of dollars being outpoured in order to address the impacts of this 1.5 degrees temperature change, or temperature, overshooting that 1.5 degree threshold, basically. So yeah, that's basically from me. So if you have questions more along those lines, I'm happy to take them to the extent that I can answer them. Otherwise, I'll try and put you in touch with somebody that might be able to. Otherwise, if it's science, I'm unfortunately, Myles, that's going all the way to you, because not my forte.
Well, thank you very much. And so we wanted to put these discussions into that context. And one of the questions I've really got for the audience actually is people here who know probably much better than I do, and it also a question for Kaya as well, is to where in negotiating the Paris long-term temperature goal, we see from outside the structured expert dialogue was there. The structured expert dialogue was there, which said we were now at 0.85 degrees of warming. Was that an important number? Because it would really help the academic community to sort of know where the Paris Agreement negotiators thought we were when they agreed this long-term temperature goal. Because at the moment, lots of academics are spending a lot of energy trying to work out what pre-industrial means. And I suspect that actually the Paris negotiators were completely clear that they were clear that they were unclear what pre-industrial means, but they also didn't care in that, you had a working definition, second half of the 19th century, and you went with it. But I'd be really interested to know if anybody in this room knows more than I'm sure there are people in this room who know more than I do about this whole pre-industrial question.
Thank you. Good afternoon. I wouldn't talk about the pre-industrial question because I think none of us was there. So no. So my name is Balisi Hopola. I'm from the Botswana delegation here. Yeah. I'll talk to two things. You did mention the structured expert dialogue, which I happened to participate in. Remember, it had a mandate to look at the adequacy of the long-term global goals, the 2013-2015 review process. And this where now we're assessing the adequacy of the long-term global goal, whether it was adequate. And I think one of the key outcomes was it was not. That's why we had to upscale. And it also informed the 1.5, and it informed the Paris on the 2. And when she rightly said 1.5 is good for the islands, but I want to also say Africa was pushing for a 1.5 goal, because we felt it was the only temperature threshold that could ensure our survival. And then, yes, we came out with that figure. The 0.85 was not just a magic number, it was out to number crunching. And you also recall that the AR5 was problematic in some of the key findings. One of them was one page in there which was problematic with some of the countries. And they assumed it was an outlier because some numbers were not well informed, and nonetheless it informed the Paris. And last but not least, you also mentioned the Kigali Amendment, which informs us on the phasing out of the HFCs. But I didn't quite get the impact of the Kigali. There's so much hype now that if all parties had to ratify Kigali and implement it, and by 2050 we could see a significant temperature drop, which is, point something of a degree. And I want you to talk to that because it's a bit technical. I wanted to come to that, but I didn't quite have the time to. And then with Kigali coming in, we could see something, because it said Kigali Amendment, it said plus the maximum reduction of HFCs, because we see potential in that. But it's bringing HCs anyway. And then on the 800 gigatons of CO2 that you mentioned, it's very interesting here because when aggregate impacts of NDCs were taken on board, we could clearly say they were not adequate enough. Some were not ambitious. So I want to see if we can apportion any figure to who. We are negotiating this time. Any figure of the 800, who should do what, but we still feel that some people are not doing enough. Thank you.
Well, those are a series of challenging questions. I'll leave the last one to Kaya. How do we apportion 800 gigatons between countries? Because that's one for the lawyers. But on the Kigali Amendment, this figure here from the UNEP Gap Report gives you an indication. It doesn't look that big on this figure, but actually this figure only goes to 2050. And if these HFCs have a long-term impact, and the chemicals which have been phased out would, if there were no Kigali Amendment, that gap would have continued to grow towards 2100. And so that's a very important development. We have addressed that. And it adds to this additional mitigation potential on non-CO2 gases that are not necessarily taken into account in all of these scenarios. So taking those opportunities is really important. On the point about the different countries pushing for the 1.5 degree goal, yes, actually, one of the things we've noticed recently, we've been looking at the level of warming countries have experienced already, and in fact, I just noticed quite recently. Botswana has actually experienced in that part of Africa a very high level of warming already. In fact, temperatures have risen more than 1.5 degrees in Botswana already. And in fact, 2/3 of the world's population has already experienced more than 1.5 degrees. So when you realize when we're talking about 1.5 degrees as a global goal, there will be a large fraction of the world that will be well above that, and that's very important, of course, to take into account in thinking about impacts. It's particularly relevant in the case of Botswana, because you're raising that here. On what this means for countries' responsibilities, one point that I drew attention to, this is, I should stress, this is a schematic. Whenever you see a nice, helpful diagram like this with just one line on it and, you know, and no real error bars, you should be very careful. It's just an indication. But, you know, it is below the Paris pledges, but if you went sort of, and what matters for long-term warming is the area under this curve. So if we do only meet the Paris pledges, and then somehow manage to reduce really fast after that, then we would still have some chance of meeting, if we did this, we would still have some chance of meeting the 1.5 degree goal. But notice the steepness of this curve, that the longer you put off reductions, the steeper that gets. And then you've got the big question of, you know, can we really commit the world to reducing at that very rapid rate? And this is the time of the century when countries, the lower income countries today, will be industrializing most rapidly. Do we really want to say that's going to be the time when we're going to reduce emissions fastest? I mean, that's the big sort of ethical, sort of intergenerational ethical question. But I think Kaya might be able to speak to this at least. At least you know what all the issues are.
So I've been tapped on the shoulder and just told that this is probably, we're fast, you know, heading towards running over time. So this will probably be the last, you know, official question. And then if we'll all be around afterwards if anyone has other questions specifically for us. But the question of how do we allocate an 800 gigaton carbon budget, I wouldn't even know where to begin with that. I feel like we'd just be heading straight back to the same old fights that countries have been having since Kyoto around Annex 1 and non-Annex 1 and, you know, common but differentiated responsibility, and these issues around developing countries now arguing that we also need to be given an opportunity to develop and build up our economies and our infrastructure at the same rate that potentially that developed countries have done. And so I feel like that allocation is going to be a messy fight if we're having to do something like that. I suspect many countries might be, you know, rather apprehensive to get into those old debates because of the fight that it would cause. And I feel like if we're playing a numbers game, developing countries do outnumber developed countries. So the numbers are on our side in that respect for that argument. But developed countries do have some heft in the game, and that has always been the issue with larger countries like, you know, the States, going back to the same arguments that they've been running since Kyoto. And, you know, why should they have to cut their emissions when, you know, the population is skewed towards developing countries, and the emissions are skewed towards developing countries, and then China and their emissions. So it'll be if it comes down to it, and if it's a question that is raised within negotiations, it would be an ugly fight. I don't anticipate it being an easy one. Yes.
Can we just take one?
Well, we could, but Henry's...
In fact, it is the most scientific and excellent presentation. But, you know, it is just said that the current pledges are insufficient. I'm a social engineer, you know, I work with the society and particularly the youth. How can we make, you know, the current pledges sufficient? That is the most important question. And in this presentation, I shall be very grateful if some light is thrown on that. How can we make the present pledges sufficient?
I think. Well, we can take that. Can we fit in one last question, please?
In some ways, it's a comment that I'd love to get your thinking on maybe afterwards, if you're out of time, which is related to your question about how we make the pledges sufficient. Yeah. It seems to me that we need some new math, you know, from an academic perspective, that what we've been doing is looking at emissions reduction. And what we have here is a problem with potential lock-in of too much fossil fuels into the system, because the pledges are not ambitious enough, the action is not ambitious enough, and the theory was that we as a world do emissions reductions and then the market constrains supply. Well, we don't have time for trickle-down economics anymore. And so they're certainly led by Pacific Island nations with the Suva Declaration. I think we're seeing a new momentum here at COP to talk about supply and to talk about fossil fuel to talk about a managed decline requirement for countries in their NDCs, which is could be part of enhancing ambition, and starting with the wealthy countries. Who gets that 800 gigatons? Well, the wealthy countries should be not doing any new exploration, because the basic math, when you add up the Rystad database, shows us that we already have enough oil, coal, and gas under production or construction to take us past 1.5 degrees. So any new projects today, whether it be fracking in California or tar sands in Canada or anywhere, take us past 1.5 degrees. I think we need to be talking about fossil fuel supply here at COP.
Thank you. So I think, yeah.
I think that's a great note to finish on, actually. Thank you very much. Yeah.
Exactly. So thank you everyone for joining us here today. If you have any other additional questions, we will be around for a few minutes afterwards to have a chat. Yes, I hope you guys enjoyed the rest of your afternoon and the rest of your COP for those who are staying on. Thank you.
Thank you very much.